The history of astronomy is on the verge of a monumental shift. It is clear that we will soon look back and divide the story of our exploration of the universe into two distinct chapters, before the Webb and after the Webb. The advent of the James Webb Space Telescope, JWST, marks the beginning of this new era, where the boundaries of space and time are no longer confined by the limitations of earlier telescopes. This incredible observatory, launched with ambitious goals, is now revealing cosmic secrets that were once thought to be beyond our reach. What is happening right now is truly groundbreaking. We are witnessing discoveries that challenge everything we thought we knew about the universe. Are these revelations due to mistakes in our observations, misinterpretations of data, or are we simply confronting something nature has hidden from us all along, a new kind of dark matter, an entirely unknown form of dark energy, or some other surprising phenomenon? As thrilling as it is to imagine, this may be just the beginning of unraveling an entirely new chapter in cosmology. The magnitude of what is unfolding before us is staggering, and it's impossible not to feel a sense of awe at the vast mysteries of the cosmos that we are now beginning to unlock. To understand the astonishing discoveries unfolding today, we must first take a journey back in time to the very beginning of the universe. According to the Big Bang model, our universe came into existence approximately 13.8 billion years ago. At that time, it was an incredibly hot and dense state, nothing like the vast cosmos we see today. But from this chaotic origin, the universe began to expand, cooling over time and giving rise to the structures that we observe in the night sky. In the early stages of this expansion, the universe was filled with a hot, dense fog of charged particles and light, preventing light from traveling freely. This was a time before the formation of atoms, and everything was in a state of constant interaction, with particles and photons scattering off each other. However, as the universe continued to cool, protons and electrons combined to form neutral hydrogen atoms. This event, known as recombination, left behind a faint glow that we now detect as the cosmic microwave background, CMB. This glow, often referred to as the baby picture of the universe, gives us a glimpse of what the cosmos looked like just a few 100,000 years after the Big Bang. Even though the universe was now transparent to light, there was still one significant problem: there were no stars or galaxies to shine brightly. Instead, the universe entered what we call the Dark Ages, a period lasting for millions of years where the cosmos was eerily silent. During this time, the universe grew larger and colder, filled only with neutral hydrogen and a small amount of helium. Without visible light or any other light sources, the universe was nearly invisible to us, except for the faint glow left by the CMB. Eventually, the matter in the universe began to clump together under the influence of gravity. The clumps of dark matter and regular matter started to attract gas, and over millions of years, these pockets of gas became dense enough to ignite the very first stars. These stars, known as population 3 stars, were unlike anything we observe today. They were incredibly massive, sometimes hundreds of times the size of our Sun, because they formed out of nearly pure hydrogen and helium. The lack of heavier elements meant they could not cool down as efficiently as stars form today. This made these early stars much larger and hotter than anything we know now. These first stars burned through their fuel quickly, living short, violent lives. When they died, they exploded in a brilliant burst of light called a supernova, releasing enormous amounts of energy and enriching the surrounding gas with heavier elements. These explosions helped seed the universe with the building blocks for future stars and galaxies. At the same, it is at this point that we enter one of the greatest mysteries of the cosmos: how did these first stars and galaxies form, and what did they look like? Traditionally, scientists believed that these galaxies could only form long after the Dark Ages, but the findings from the James Webb Space Telescope are shattering these assumptions. The JWST was designed specifically to peer into the deepest corners of space, beyond the reach of any telescope that came before it. Unlike the Hubble Space Telescope, which primarily observes invisible and ultraviolet wavelengths, JWST is equipped with cutting-edge infrared technology. This allows it to detect the faintest and most distant objects in the universe, including those that existed when the universe was still very young. The JWST's infrared vision allows it to see through the cosmic fog created by hydrogen clouds, giving us unprecedented access to the universe's earliest moments. In its first few years of operation, JWST has already made jaw-dropping discoveries. One of the most surprising findings is the detection of massive galaxies, ones much larger and more mature than models suggested should have existed so early in the universe's history. These galaxies appear to have formed just a few 100 million years after the Big Bang, a time when cosmologists believed the universe was still in its youth, with galaxies only beginning to emerge. How could such massive structures have appeared so early in cosmic history? This discovery is challenging our understanding of galaxy formation and forcing us to reconsider the timeline of the universe's evolution. Adding to the mystery, the JWST has also detected supermassive black holes in these ancient galaxies, objects that are millions, if not billions of times the mass of our Sun. Traditionally, scientists believed that supermassive black holes took billions of years to grow to such sizes, slowly accumulating mass as they absorbed stars and gas. But the detection of these massive black holes so early in the universe raises a tantalizing question: could black holes form much faster than we thought? There are several theories that could explain this, including the idea that giant gas clouds might collapse directly into black holes without forming normal stars first. Another possibility is that primordial black holes, formed in the very earliest moments of the universe, could have merged to form these supermassive objects. Whatever the explanation turns out to be, this discovery is forcing astronomers to rethink everything we know about black hole formation and growth. At the heart of these discoveries is a serious challenge to our existing models of the universe. The lambda-CDM model, which has been the cornerstone of cosmology for decades, suggests that galaxies should form gradually, building from small clumps of dark matter and gas over time. The discovery of massive galaxies and supermassive black holes in the early universe has created tension with this model, prompting some astronomers to consider the possibility that our understanding of cosmic evolution may need a significant overhaul. Could these discoveries point to something new, something unexpected about how the universe works? Some researchers have even suggested that exotic forms of dark matter or dark energy could be involved, potentially influencing galaxy and black hole formation in ways we hadn't imagined. Others are questioning whether the rate of star formation might have been faster than previously thought. Another intriguing possibility is that the universe itself may be far older than we realize. Could our current estimates of the universe's age be wrong, and could we be looking at evidence that the cosmos has experienced more than just a single Big Bang? The idea of a cyclic universe, where the universe goes through endless cycles of birth, death, and rebirth, is gaining attention once again, particularly with the work of physicists like Roger Penrose. While these questions remain open, one thing